So today, guys, we're going to have a look at binomial expansion, and this is not something that's going to be super new to you, but we're going to take a little bit further than we've looked at this stuff before. Now, binomial. So the topic of this video was binomial expansion. Expansion is pretty self-explanatory. Expansion means to get larger, expand it. Now, binomial, it's not super obvious, but if we break it down, it's not too bad. Bi. That means two. Okay, so that's like a bicycle. Bicycle, two wheels. Bi in this case also means two, and nomial. All right, doesn't mean gnomes. Spelled with a G. Nomial in this form means number. So basically, binomial means two numbers, and we're going to be looking at expanding things that have two numbers in them. So the way we're going to represent these two numbers is the first one is going to be, let's call it A. All right, and the second one is B. So if we add those two together, we have two numbers, A plus B. This is a binomial. So where do we go from there? We've got our binomial, A plus B, but we've got to add the expansion part. Now, the way we're going to expand this is by using powers or indices. So as I introduced you before, A plus B is a binomial. In this case, A plus B is the same as writing A plus B to the power of 1. That's kind of a 1. You can see that. So A plus B to the power of 1. Now, if we were to expand that, anything to the power of 1 is just itself, so that will just equal A plus B. Now, we also have a couple of other ways of expansion. So we don't just always have 1. We can have 2, 3, or up to n. Now, n, that can be any number. All right, so I could number. Wow, this is terrible. Any number. All right, we're back. I've gathered my thoughts, and n is any number. All right, so that could be, n could be, we've got 1, 2, 3, it could be 4, it could be 5, it could be 7, it could be 100. Any number we can expand to, and we're going to learn a trick to how we do this. So let's have a crack at that. So if we expand A plus B, like we said, as A plus B to the power of 1, that's going to be just A plus B. Okay, there's no real expansion there. Now, when we have A plus B squared, we can write that as A plus B times by A plus B. And there's several ways to do this. You might have heard of the term FOIL. So first, outer, inner, last. So if we times the first two together, we got A times A. That equals A squared plus the inner, B times A. So I'm just going to write AB. It's the same thing, AB, BA. Plus the outer. So again, A times B. Plus the last, B times B, is B squared. Now I can gather these. A, B are their like terms, so I can gather those together. So I can write A squared plus 2AB plus B squared. All right, and we've seen this with our quadratics and expanding before, so this shouldn't be anything new to you. So A plus B squared expands to A squared plus 2AB plus B squared. All right, now if I was to expand A plus B cubed, the answer I'd get is, and I'm not going to show this, but you just have to believe me here, I'd get A cubed plus 3A squared B squared. Oops, sorry, not B squared, just B, plus 3AB squared plus B cubed. Okay, now this has a very important pattern that we're going to see in a minute. Now, if I've got my A cubed by itself, that's the same thing as writing 1A cubed. And if I've got my B cubed, it's the same as writing 1B cubed. So we're going to, the reason I've written that will be clear in a minute, but for now, we're just going to leave that in a memory bank. So what I wanted to introduce you to now is Pascal's Triangle, and this is going to be the way we see how to expand these really easily. So Pascal's Triangle, we describe these things as rows. There's going to be a certain amount of rows, and what I've got in the top row is two number ones. So these are number ones. Now, each row, as you go down, it adds one more value. So we've got 2 in the first one, then we add another one on the as we go down. So the way we do that is if we move we're going to move slightly out on either side. Now, as we move on the outside, these are always going to be 1s. So again, if I keep moving down, there's going to be 1, and it's going to go on forever like that. And the same on the other side. My 1s are going to run down the outside. You don't have to draw the arrows. I've just drawn that because it's the first time we've looked at this. Okay, there's the worst triangle ever. But the number between them, where that comes from is, instead of dropping down this 1, we drop down a 1 from each side and we add them together. So if we drop down a 1 and a 1, we get 2 in the middle. Okay, and you can see in row 1, so this is row 1, we've got 2 1s. In row 2, we've got 3 numbers. Okay, row 3, we're going to have 4. So we get the drop down of our 1, and then we get this number here is going to be 1 plus 2 is 3, and this one's going to be 2 plus 1 is also 3. And again, we keep dropping down. We get 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and it keeps going on like this forever. Now this seems pretty random, and it's actually really, really useful. So if I was to draw my other line, my next line just quickly, I've got 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 on the outside. Okay, and it keeps going on that forever. There's no end to it. There's n numbers, and that's a bit of a hint. All right, so let's get back to that expansion. Now, what I want to do is I've got up here Pascal's Triangle. Often it's written with a 1 right at the top, but we don't care about that. We're not interested. So what I want to do is label this. So this is row 1, just R1, row 2, row 3, etc. Now, row 1, that corresponds to A plus B to the power of 1. So row 1 and power of 1. Now, what these numbers here mean is these are the numbers that go in front of our value. So what I mean by that is we're going to have 1 and then our first number, A, plus 1, and then our second, which is B. Now, you don't need to write the 1s. You can just write A plus B. Okay, but that's what it expands into. Now, if we go to the second one, A plus B squared, that's going to equal, we go to our row 2 because it's squared. So 1A, we don't need the 1, so I can just write A plus, and okay, because it's squared, we always start with the squared in there as well. So it's going to be 1A squared plus, now I take 1 off that A, so it becomes A to the power of 1. And I give 1 to the B, so that becomes AB. And I put that number 2 in there from here. All right. And then finally, my last value is I take 1 away from my A and give it to the B, so I'm left with B squared. All right. Let's do a couple more of these. So A plus B to the power of 3. The first thing I'm going to write is A cubed. So we're on row 3 now. So 1, A cubed, plus, our next value is 3. And I want to do my A, not cubed, minus 1. All right, so if I minus 1 from there, I have to add 1 to the B, plus, next one is 3, 3A. So I've taken 1 again, given it to the B. Last one is plus B to the power of 3. So you can see as we go across, the A's are getting smaller in terms of their power, and the B's are getting larger. All right. So how many rows have we got? We've got 4, 5, 6, 7. So we've got 7. So let's do, just imagine that goes on forever, and I've got A plus B to the power of 7. So the way that would work is I'd have A to the power of 7 plus my next number is 7. So I'd have 7, A to the power of 6, B, plus, I've got my plus 21, A to the power of 5, B squared, plus 35, A to the power of 4, B cubed, and again 35, plus 35, A cubed, B to the power of 4, plus 21, A squared, B 5, plus 7, A, B to the power of 6, plus B to the power of 7. Okay, so instead of expanding and adding all of these terms and then having to collect them, we can use this Pascal's triangle as a really quick way of doing this. Okay, so let's have a look at a couple of quick examples. So the first one I've got is 1 plus x to the power of 4. So I want to go back to my Pascal's triangle and look at row number 4. And the numbers are 1, 4, 6, 4, 1. So my numbers are, I'm just going to make a quick note of that. 1, 4, 6, 4, 1. So when I'm expanding this, what I'm doing is I've got 1 times by my first number to the power of 4 plus 4 times by that first number to the power of 3 times by that second one to the power of 1 plus 6 times by 1 squared plus, times by x squared plus 4 times by 1 to the power of 1 times by x cubed plus x to the power of 4. Okay, so let's have a go at this. So 1 times by 1 to the power of 4 is 1 plus 4 times 1 is 4x plus 6x squared plus 4x cubed plus x to the power of 4. Okay, so that's what my binomial expansion equals. Now, what I want you to do is, I don't want to talk too much longer, so what I want you to do is have a crack at this one yourself. If you have any problems, just let me know. All right, so thank you.